Hi, in this video we will review the definition of trigonometric ratios using the right triangle, and then at the end we will show how to evaluate these ratios for some angles and use these ones when we have one we can use it to find the other ones. Okay, so the story of the trigonometric ratios starts from this point that for any given acute angle theta, well, what does acute mean? It is an angle between 0 and pi over 2. We can find a right triangle with theta as one of its angles. Well, right triangle means that already one of the angles is theta, pi over 2, and then other angle of this triangle is theta. We can always find such a thing. It's not difficult to see. But the issue with this construction is that it is not unique at all, meaning that someone in somewhere else can make exactly same such a right triangle but with different sides, meaning that, let me show you how. Just I will put this one there, and then you see this triangle that I just draw has exactly same angle theta. It's the right triangle with the same angle, but the sides of this triangle is completely different than the ones that we had before. In other words, if I denote the adjacent side, the length of the adjacent, this is called the opposite side with O, adjacent with A, and hypotenuse by H. The opposite of theta, the opposite of theta here will be capital O, and this will be capital A, this will be capital H. There is no uniqueness, and there is no that capital H can be completely different number and capital A and capital O. But as a fact from the Euclidean geometry, we know that every such two triangles are similar, and well, as a result or as a definition, although H, O, and A are different than capital H, capital O, and capital A, but they will have the same ratio. What does it have for us? So if you take this thing and just switch O and H, take this equality on OH, you see that O over H, opposite length of opposite side over the hypotenuse, in both of these triangles, this ratio is the same thing. You can also take these two, and you will see that the ratio of the adjacent over hypotenuse for these two triangles, or any two triangles with this property, are the same. And also adjacent over opposite over adjacent of such triangles are going to be same. No matter OAH are going to be different thing, but the ratio are going to be the same. That's where trigonometric functions come in and say that, okay, then we take it. This constant, we will call it sine of theta. Doesn't matter which one I use, opposite over hypotenuse. Take this other one, you call it cosine theta, adjacent over hypotenuse. Take this one, opposite over adjacent, and call it tan theta. And then more things. For example, cosecant theta would be h over o. Or secant theta will be h over a. And cotan theta will be just adjacent over opposite. Well, very quickly you can see that this is inverse of the other one, meaning that cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. And while cotan theta is 1 over tan theta. Also, you can see that tan theta is sine theta over cosine theta. And these are called trigonometric ratios. Well, now everywhere. They are everywhere in engineering, in math, and in all the world. Okay. Well, let's do just one example. Find all trig ratios of theta if, well, we have a right triangle with sides 2 and 3. Very nice. Okay, if this is 2, that basically means that opposite is 2, and this means that hypotenuse is 3. How about adjacent? Adjacent is not given, but we can use a Pythagorean theorem. So h squared equals to a squared plus o squared. And this gives us 3 squared equals to a squared plus 2 squared. And then you just do a is root of 9 minus 4, which is root 5. This is the length, so we just take positive root. So we find the other one. Now that we have opposite, adjacent, and hypotenuse, then we can go ahead and find sine theta. It is opposite over hypotenuse. In this case, it is 2 over 3. Cosine theta, let me go up a little bit. Cosine theta is adjacent over hypotenuse. This is root 5 over 3. And tan theta is adjacent over opposite. Oh, sorry, the other way around, the opposite over adjacent. Opposite over adjacent. So it will be 2 over root 5. And then we can rationalize the denominator and get 2 root 5 over root 5. Then cosecant theta is 1 over sine, which is 3 over 2. Secant theta is 1 over cosine theta. This gives us 3 root 5. And then rationalize this will give us 3 root 5 over 5. And then cotan theta is 1 over let me just use this one, and that gives us root 5 over 2. Well, that's now nice. So if you know two sides of the triangle with angle theta, you can find all the ratios. There are few triangles and angles for which we have to know all the trigonometric ratios. This one of them comes from the equilateral right triangle. So if this and that are the same, then these angles need to be pi over 4. And then while you have 1 root 2 here, there's another triangle which we will call these ones reference triangles. The smaller acute angle is pi over 6, the bigger one is pi over 3, and then this is 1, 2, root 3. And then using those ones, you can have this table of values, and you have to know these ones by heart. Pi over 6, pi over 4, pi over 3. Well, I will add 0 and pi over 2 here just to have the table ready for now. Sine theta. For this is 0, this is 1 over 2. It's a good time to pause and use the definition and the triangles given up there and check that you can find these values. So this is half root 2 over 2. This is root 3 over 2, and this is 1. For cosine theta, you have 1 root 3 over 2, root 2 over 2, 1 over 2, 0. And then you can find all the other ratios using these ones. For example, tan theta, 0 over 1. It is sine over cosine. This will be 0. This will be 1 over root 3, which is the same thing as root 3 over 3. This is 1. This is just root 3, and this is not defined. So tan of pi over 2 is not defined. This is always the case when you have some information about the one of the ratios. You can find almost all of them. Let me do one more example for the values of the trig ratios, for which, okay, so find all trig ratios of the acute angle theta which satisfy tan of theta is 1 over 3. I don't know what is theta. I don't know what are the other ratios, but just looking at this thing, that tan theta is going to be opposite over adjacent, and then any triangle I draw, this ratio is going to be the same thing. So this, if this is theta, this over that will give me 1 over 3. So then why don't I put, this is 1 over 3. Why don't I take this as 1 and this as 3? These are going to have exactly same ratio. So this will be 1, this will be 3. And then using the Pythagorean theorem, you get h squared is equal to 3 squared plus 1 squared, and that is 9 plus 1, and as a result h is root 10. So this is root 10. When you have all of these, then you can go ahead and find sine theta, which is opposite over hypotenuse. That you rationalize, you get this. Rationalize the denominator. Cosine theta, this is adjacent over hypotenuse. Rationalize the denominator, and you get this. Tan theta, this is opposite, well, already we had that. Now cosecant theta is 1 over sine theta, which is root 10. Secant theta is 1 over cosine, and that is root 10 over 3. And cotan theta is 1 over tan theta, which gives me. And well, you have to be able to find all trig ratios if someone gives you only one of the ratios, the trig ratios. This was the review of the definition of the trigonometric ratios based on the right triangle.